Hello everyone, welcome back to my channel Learning Fundamentals by Ankit Shukla. I hope you're all doing well. Today we are going to learn about the classes of IP addresses, IP subnet and subnet mask, different types of networking devices like router, modem, switch and many more. If you haven't watched this chapter 1 of this session, please go to the description of the session below or subscribe to this channel and check the session 1 of this series. Let's get started with this video. All right, guys, this is chapter 2 of the learning fundamentals. As I explained in the introduction, we are going to talk about the IP addresses, the classes, the IP subnet, the subnet mask, and the networking devices. So first on the list for this session would be IP address classes. IP addresses are essential for identifying and communicating between devices on a network. They are like unique postal addresses for devices in a network. Here's a breakdown of how and what IP addresses are and what different classes they come in. As I explained, an IP, which is Internet Protocol Address, is a numerical label assigned to each device connected to a network that uses the Internet Protocol for communication. It serves two main functions. First one, identification, which means it identifies the network. It identifies the device on the network. Then it talks about the second part, which is the location addressing, which is to provide the location of the device on the internet or the network so that data can be sent to and from it. An IP address is a series of numbers separated by dots. It looks something like 192.168.1.1. It's a 32-digit number divided into 8-bit sections called octets. So there are 4 octets, 8-bit sections, and 32-bit number, which means each octet has 8 bits. And each octet can range from 0 to 255. So as an example, if you see this IP address 192.168.1.1, it has 32 bits, which means it has 4 octets, 192, 168, 1.1. So 192 represents one octet, 168 represents the second octet, and similarly 1 and 1 represent two other octets. Altogether, they make up 4 octets in an IP address. Each octet has 8 bits, irrespective if it is a 3-digit IP, 2-digit IP, or the class as in 192, it has 3 numbers. It still has 8 bits. Similarly, for 168, it has 3 numbers, but it has 8 bits. Similarly for 1 and 1 as well. So altogether, 32 bits, 8 bits on each section, and each section is called as octet. Next, if you look at this diagram, it talks about the IP address formats. IPv4 and IPv6 are the two commonly types of IP address. Most commonly, IPv4 is still used in the market or in the global world. IPv4 consists of 4 decimal numbers separated by periods. Each number is between 0 and 255. On the other hand, IPv6 addresses are longer and are written in hexadecimal format separated by colons. They provide a larger address space than IPv4. Just so you know, IPv6 is used in modern devices, in modern technology. You can say from past 5 or 7 years, it has been in use. But still in the world, we still are heavily dependent on IPv4 addresses. In the diagram, you can see on the right hand side, there are multiple IP addresses that you can label. They are in different classes, and on the left hand side you can see the diagram that I explained in the chapter 1, like public IP address, private, static and dynamic. Next up is the IP address and its classes. So IP addresses come in different classes to accommodate various sizes and types of networks. Each class has a specific range and default subnet mask, determining the number of devices that can be addressed within the network. Understanding these classes helps in designing and managing the network infrastructure effectively. There are 5 classes of IP address: class A, class B, class C, class D, and class E. Let's look at how these classes look like. If you see in the next page, it says it looks like a schematic representation of how the IP addresses is divided into classes or its subjective range. IP addresses in whatever classes have a network portion and a host portion. Each portion represents an octet, meaning we have 4 octets in an IP address with a combination of 1 or 3 network and host portions. We'll talk about that in the later part of this video. Each octet represents 8 bits and hence an IP address is of 32 bits. If you see in this diagram, it says class A, class B, class C, class D, class E. The starting range of class A is 0.0.0.0 to 127.255.255.255. That's the range of class A, and similarly for class B, C, D, and E. Next, we are going to take a closer look at class A IP addresses in the world of computer networks or digital world. Class A IP addresses are designed for very large networks with a massive number of hosts. They are identified by their leading bit pattern and a specific range of addresses. They have a subnet mask. The default subnet mask for class A is 255.0.0.0, which indicates that the first 8 bits are used for the network portion, while the remaining 24 bits, the remaining 3 octets, are available for the host address. Number of networks and hosts that can be there in a class A IP address would be 128 for networks, basically from 1 to 126 with the first bit set to 0. And then the host can be up to 16 million and above. Due to their large number of available host address in class A networks, they are typically used by very large organizations, or you can say internet service providers or corporations with a very extensive infrastructure. Let's say for organizations which have a broad exposure across the globe. For let's say a university which is based out of different geographies, they may have different set of IP addresses, and that's where class A IP address is reasonable and uh, perfect for them, wherein they can expose their network or have multiple and huge sets of devices which they need to address and connect to the network, and that's where class A IP address is absolutely perfect for them. The advantages of class A IP address are that they are highly scalable, because with millions of possible host addresses within a class A network, it can accommodate a vast number of devices, making them ideal for large organizations. The second advantage we have with class A IP is the simplicity, because the default subnet mask of class A IP, as I explained earlier, is 255.0.0.0. It simplifies the network configuration and the management. In short, class A IP addresses are a critical part of the IP address hierarchy, which are designed to support the largest and most complex networks. They provide the scalability and simplicity needed to manage extensive networks and their environments effectively. As you can see in this example, we have 2 IP addresses, 12.0.0.1 and 100.10.12.3. The first octet in both of them, let's say for the first one, it is 12. It represents the network portion, and the remaining 3 octets like 0.0.1, they represent the host portion. Similarly, for the other IP address in this example, 100.10.12.13, 100 represents the network portion, and the remaining 3 octets, that is 10.12.13, they represent the host portion. Now we move on to class B IP addresses. They are designed for medium-sized networks and offer a balance between the number of available networks and the number of hosts per network. Here's a detailed lookup at the class B IP addresses. They have a network range from 128.0.0.0 to 191.255.255.255. Example of a class B IP would be 172.16.0.1. It's a class B IP address. The subnet mask for this class B IP address is 255.255.0.0, which means it had 2 octet for the network portions and the 2 remaining octets for the host portion. You can think of an university with multiple departments and buildings. A class B IP address could serve the needs for a similar kind of departments or a building or a university in a better way, but compared to a class A, which means an organization which is not that big, but yes, they still need multiple range of IP addresses. They also have a global exposure, but not are as big, or they don't have no more, number of devices as huge in count compared to a class A IP. If you look at this diagram carefully, the network and host portion in this piece, this is a class B IP. So the network portion, the first two octets, as I explained, 16 bits, each octet is 8 bits. So two octets over here are dedicated towards the network portion, and the remaining two octets are for the host portion. Again, 16 bits for the network, 16 bits for the host. Number of networks that can be there in a class B IP is 2 to the power of 14, that is 16,000 plus approximately 16,384 networks, and the number of hosts per network would be 2 to the power of 16 minus 2, which is 65,534. So in short, number of networks that can be there in a class B IP is 16,384, and the number of hosts per network would be 65,534. In this diagram, you can clearly see there are two IP addresses, one at the top, one at the bottom. The first two octets, for the first one, that is 130.11, that represents the network portion, and the remaining two, 12.30, that represents the host portion. Similarly for the other IP address as well. All right, now we move on to class C IP addresses, which are commonly used for the small networks like those found in small businesses or home environments. They provide a large number of individual networks with a relatively small number of hosts per network. Class C IP address has an address range from 192.0.0.0 to 223.255.255.255. The default subnet mask is 255.255.255.0. This means that the first 24 bits, which means a 3 octet at the beginning, are the IP address which is used for the network portion, and the last 8 bit, or you can say the last octet, is used for the host within the network. The number of networks and hosts vary drastically, or they are very less compared to class B or class A. The number of networks in class C would be approximately 2 millions. It's actually more than that slightly. Then the number of hosts per networks would be 254. All right, this is a schematic diagram of a class C IP address. The first three octets, as I explained in the previous 10 seconds back, they are dedicated towards the network portion. So basically meaning the first three octets are dedicated for the network portion. The last octet, 101, as you can see in this diagram, is dedicated towards the host portion. And the other example, you can see that as well, 210.55.10, that represents the network portion of this IP address, class C. And the last one, which is 105, the last octet of this IP address, that represents the host portion. All right, now we move on to class D IP addresses. The class D IP addresses are used in multicast applications wherein data is transmitted to multiple devices simultaneously. This is a commonly used IP address class in streaming media, online gaming, stock markets, financial feeds, video conferencing. This video right over here, this is actually recorded on a class C network. However, when it is transcoded over a video, or you can say passed on or transcribed to a video, it goes through a class D IP address. Examples of a class D IP address are, first we have to talk about the ranges. The ranges are 224.0.0.0 to 239.255.255.255. The example could be 239.192.0.1. This is a class D address because the first octet 239 falls within the class D range. The class D range here is 224 to 239. This address would be used to identify a multicast group rather than a specific device. Basically, these are identified through a multicast group channel rather than a specific individual device. The advantages of a class D IP address is that it can multicast. It is because of multicasting, it is more efficient, right? And it reduces the network bandwidth usage by sending a single stream of data to multiple recipients. It's like multicasting your information towards multiple recipients rather than separate streams or dedicatedly transferring the data to individual hosts. It is highly scalable. It allows for scalability, or you can say a delivery of content to many users without even any impact to the network or the bandwidth. In short, you can say that the Class D IP addresses are vital for multicast communications, enabling the efficient and scalable data distribution to multiple recipients. They play a very crucial role in applications where simultaneous data delivery to many users is required. Think of that as an example of a soccer match which is live telecasted. That's an example of a Class D IP address. There is no subnetting as well in Class D IP address. The last class in the classes of IP is Class E IP address. The Class E IP address example would be 250.1.1.1. Their address range starts from 240 to 255, basically in precise 240.0.0.0 to 255.255.255.254. Why we have Class E IP address? These are typically used for testing or experimental or research and development within a very closed or secure or maybe confidential environment. The advantages of Class E IP addresses are that they are used for future proofing because they provide a reserve IP range for potential application testing or development. Then for research and development, they are highly uh, useful. These addresses are available for testing new protocols. Anything that you see in future uh, or you hear about it, understand it that there has been a lot of work or testing done on that application or that product, but that is happening on a Class E IP address. In short, you can say that the Class E IP addresses are reserved for experimental use and future needs, offering flexibility and the potential for innovation in the network research. They play a very crucial role in allowing the exploration of new technologies without impacting the existing IP address space. When we talk about the classes of the IP addresses, basically IP addresses come in different classes to accommodate various sizes, types of networks. Each class has a specific range and a default subnet mask, as I explained, determining the number of devices that can be addressed within the network. Understanding these classes actually helps in designing and managing the network infrastructure effectively. That's the end of the classes of the IP addresses. We'll now move on to the IP subnet and subnet mask. A simple definition of subnet is logical subdivision of an IP network. It allows a large network to be divided into smaller, more manageable networks. Subnetting helps in improving the network performance, security, and efficiency by segmenting traffic and isolating the network issues. On the other hand, subnet mask, it's a 32-bit number. It is often represented in dotted decimal notations like 255.255.255.0. It is used to divide an IP address into network and host portion. It defines the boundary between the network part and the host part of the IP address. The subnet mask uses 1 bits to represent the network portion of the IP address and 0 bits to represent the host portion. As you can see in this diagram, we'll go a little deeper into the subnet and subnet mask. Imagine yourself, you are in a vast city with numerous neighborhoods, right? Each neighborhood or a community has a specific number of houses. Each house has a unique address, right? Let's think of IP network as the city, the neighborhood of that specific region within your city as the subnet, and the houses represent the individual IP addresses. Now, talking about subnetting for this. A subnet would be, in this classical example, would be like dividing the city into smaller neighborhoods. Each neighborhood can contain a specific number of houses, which means the subnets. This division helps in managing and organizing the network more efficiently. For instance, instead of having one large unmanageable city, you break it down into smaller neighborhoods or communities or regions that are easier to handle and control. On the other hand, subnet mask is like a map that tells you which part of the address is for the neighborhood or a specific subnet and which part is for the individual house. It's like having a guide that explains which part of the address identifies the neighborhood and which part identifies the specific house within that neighborhood. Is how it works. If you see this diagram, the IP address 192.168.1.10, it represents, or think of this as a address of a house in a specific neighborhood. Okay. The subnet mask for this is 255.255.255.0, right? This subnet mask basically determines how much of the IP address is used to identify the neighborhood and how much is used for the house. Now, because this is a class C IP address, as I explained in the previous section, the first three represent the network, the last one represents the host. So in this case, the subnet mask is 255.255.255.0. The first three parts represent the IP address of the neighborhood, or you can say the subnet mask. The last part represents the house, right? Now, see the diagram very carefully in the bottom section. You see 192.168.1.0 is divided into two parts. First, the network portion, that is 192.168.1, and the host portion, which is .10. It's represented in the green color if you look at the bottom. The subnet mask indicates that the first three octets are used for the network, the last octet is used for the host. This entire division helps in managing and organizing the IP addresses within the subnet, just like dividing a city into neighborhoods and houses. We now move on to the networking devices. Networking devices are hardware components which are used to establish, manage, and optimize communications between different devices on a network. Let's see that through a common example that we have in day-to-day life. First, we have internet, then we have a modem, we have a router, then it is split into a switch and an access point, and we have different devices which are connected through wired or wireless medium. In this diagram, internet represents the global network that connects different various networks worldwide. Modem, the next one in the list, is something that converts the digital data it receives from the internet into a format which can be usable by your local network. Router, on the next one, is router. It directs the data packet received from modem, or you can say from internet to your local network via modem, of course. It also helps in the built-in firewall for security. So basically a router works as a firewall for security purpose. Next we have switch. The purpose of switch is that it connects multiple wired devices like PCs, printers, and servers. If you look at that on the left hand side, access point on the right hand side, it connects different wireless devices to the router instead of a wired network, just like what a switch is doing. Now, an explanation of this diagram clearly tells you how you access the internet through a wired or a wireless medium, through a switch if you're connected via wired, through a access point if you're connected to the internet, or your router via a wireless medium. Next, we have router as the first network device. The function of the router is that it directs data packets between different networks, such as between your home and the internet. There are different examples over here. I'm absolutely sure you all have experienced them, used them in your day-to-day life. The one that shows up at the bottom, it's like an industrial router, which is used by the organizations for a bigger purpose because they have bigger range or a larger range. They need to connect multiple devices or more devices that you can assume which are not available in a home network. You can imagine router as a traffic cop for your internet traffic. It's a device that connects different networks together, like your home network to the internet. Router decides the best path for data to travel from one network to another. It ensures that it reaches its destination efficiently. Now we have switch. Imagine you are at a party wherein everyone is talking and doing chit chat. In this scenario, a networking switch is like uh, it's like the party organizer who helps the people communicate efficiently. Um, just like a party organizer ensures that the people who want to chat with each other get connected. That's the job of a switch. A switch connects different devices within a network, but instead of connecting people, it connects computers, printers, and other devices. Then we have hub as the next networking device. Imagine you are at a party again with a lot of guests. Now picture a networking hub as the loudspeaker that we have in parties. So the loudspeaker basically it broadcasts the message to everyone because everyone can hear it, right? So a networking hub basically sends data to all the devices connected to it within the network. It's broadcasting everything, whatever information it is getting, it is broadcasting that to all the devices which are connected to the hub. That's the work of a hub. Next one we have is a modem. Imagine you're sending a letter to a friend who lives very far away. Let's say I'm in Delhi. I need to send a letter to my friend who is in US. You write your letter in a language your friend understands, right? But the letter needs to travel through various postal systems, right? Through customs, through flights, the transportation, and from different formats and rules, right? So basically, that's the job of a modem. Modem is like a post office worker who handles the complex task of converting and sending your letter through different postal systems so that it reaches your friend in a readable format, right? It's like modulation and demodulation. Let's say when you talk to your friend over a phone, right? You speak, that is converted to signals. The device that converts that signal to the recipient on the other end of the phone who hears that, that's a modem. That's called as modulation and demodulation to be precise. Next in our list of network devices is the access point. Imagine you are at a busy convention center with multiple rooms and hallways, right? You want to stay connected with your friends throughout the building. An access point in the convention center would be like a series of information desks strategically placed around the venue to help you stay connected. Imagine you are in a shopping mall. I'm sure you all have visited once. If you go to a shopping mall, there probably be a dedicated network available to you within the hall in the entire shopping mall itself. If you understand it correctly, even if you're on the ground floor, you have the same signal strength when you move to the first floor, you still have the same signal strength from the same network you are connected to. What's basically happening is initially when you came into the shopping mall, you got connected to the network. Then once you walk certain meters or certain distance away from the initial device that you were connected to, it automatically connects to the next device, which is in the same network. That's the job of access point. In modern days, access points can be used as repeaters as well. Basically, repeaters is the next level of access points. So, and you get connected to different routers, but within the same network, providing the same signal strength. That's the job of an access point. Next in our list is a very important topic. It is about the firewall. Firewall is, and again, one of the network devices. It is like having a security team at your event. It controls and monitors the flow of information between your network and the outside world, making sure only the authorized and safe data gets through. Whether it is incoming or outgoing, firewall scans that. There are four jobs of a firewall. It filters the traffic. It applies the rules and policies that you choose to. It monitors and logs the incoming and outgoing traffic. It also helps you prevent unauthorized access. Next, in the list of networking devices, we have a bridge. In networking, a bridge connection, it's like two or more network segment. It joins two or more network segments, allowing them to communicate as if they were a single unified network. Just like a physical bridge connects two land masses to different areas, a network bridge connects two different segments of network. This could involve linking different LANs or connecting parts of networks that use different technologies. It filters and forwards data between these segments, learns about the devices on managing traffic and extending network reachability. Just as a bridge connects physical spaces, a network bridge connects digital spaces, ensuring smooth and efficient communication across the network. In this diagram, you can clearly see there are two hubs which are connected to bridge. So these two hubs have two different segments of network. This bridge is connecting these two hubs, and hence the hub on the left hand side can read the information about a device that's on the right hand side connected to the different hub. And similarly, other devices can be handshaked or information could be shared. Using this bridge, it connects the two hubs. All right, next, and you can say the last topic for today. It is the most important topic. This is a network gateway. Now imagine yourself, you are at a large international airport wherein different countries have their own customs and security procedures. To travel between these countries, you need to go through a custom checkpoint, security checkpoints, and all that. That ensures, that is there basically to meet the entry requirements for you, and that your travel documents are in order, like your passport, your visa, or your work permit, or your travel document. At this place, the customs checkpoint that works like a gateway. It acts as an entry point and the exit point between different networks. After converting the data formats or protocol, ensure smooth communication happens between the systems that use different set of technologies. How does a network gateway works? Just like a customs checkpoint connects travelers to different countries, a gateway connects networks that use different protocols or technologies. For example, it might connect a private network to the internet or link two different types of networks such as the corporate network and a cloud service. You might need to adjust your documents sometimes because of regulations at the securities or the customs when you go to a destination country, and properly processed by the destination network. Who does that? The network gateway. It has security and access control. Then, in short, if you have to say or summarize, a gateway is like a customs checkpoint at an international airport, facilitating communications between networks that use different protocols or technologies. It connects these networks, converts data formats or the protocol that is needed, and then it routes the traffic and often provides security controls as well. By serving as an intermediary, like, you can say somebody saving or safeguarding your data when the data is going outside the network. It ensures that the information flows smoothly, securely between different systems and making their network communications more seamless and effective. Well, this is the end of our chapter 2, the networking fundamentals, guys. Thank you so much for tuning in. I hope you find this video helpful and informative. If you have enjoyed it, don't forget to give it a thumbs up and hit that subscribe button to stay updated with all the latest content. Also, feel free to leave a comment below. I would love to hear your thoughts or answer any questions you might have. And if you have any suggestions for future videos, just let me know. Thanks again for watching. I'll see you in the next video.